Alright, hello everyone. So today I'm going to show you how to work with Python and so on. Alright, so let's dive into it. So first I want to create a class. I want to call it math. It will be inherited from the object, which is by default. So then underline init method, which is oh yeah, of course, def, and it's of course receives cells, and then just x. So I'm going to say that self that x is equal to x, and first function which I'm about to implement is going to be length function, which is basically calculates the length of the array or list. So what we're going to take is just self, because we already take it from here. So by the initialization of the class, we will take the parameter and then we'll use it in every place in the code where we are about to use it. So we're going to return, first of all, we're going to return self.x, which is going to use method which called index, and it's going to receive the value of an array and give its index. So by doing this, you can actually ask, why do you do this? Like, it doesn't help you at all. But if we will use self.x, and then we will use -1, which is the last element in the array, is going to give us the last index. So it will give us the last index, but we'll consider that we're starting with 0, which means that 0 index is taken. So we'll just add 1 to here, because I mean, the basic example of this is that I have array 1, 2, 3, which basically means that in this array 1 is the index 0, and then 2 is the index 1, and then 3 is the index 2. Okay, or if it's a little bit hard for you, I can do 6, then 12, and then probably 18. So if it's going to be easier for you. So 6 is index 0, then 12 is index 1, and 18 is index 2. So basically it means that when we will take here our last element, which is going to be 18, and we take it index is going to be 2, but actually our length is 3, so I'm going to plus 1. So this is the reason. Hope you understand correctly. And by the way, let's check this out actually right away. So what I'm going to do is I'm going to create a new variable. Is going to be x. It's going to be array, and so our just I'll use m as an object of the class. So math, and then I'm going to put x, our actual x, and then we'll work with this x, so on and so on. I'll just make in such a way. So and then I'm going to print it, and then m is going to use length. So let's check this out. It's actually supposedly must be 3, and yeah, let's check it. So we run it and we get 3. Alright, so I like it, but what about if check it with something ambiguous? Of course, I don't want to like make a range from, manually make a range from 1 to 1000, so I'll make it using the easiest method to do this. I in I, which means iterator. Oh no, of course, here's going to be for I in range of whatever. Let's imagine 1000, and let's check this out. So it must return us 1001, I believe. No. Oh yeah, of course, because we are starting with 0 and we are ending with 999. So this is the reason. So this is basically correct, and okay, I like it. So yep, in this way, that's good. So let's just by default make it empty. So yeah, we don't implement anything, so it's gonna run okay. So yeah, so the next method which I'm about to implement is going to be just sum. So I'm going to make it sum, and pass inside self, and I'm going to return something interesting right now. So basically how we can sum of an array is to go through the loop. So this is what I'm about to do. Let's go into the loop, and now you will realize the reason why. First of all, um, I have made, and yeah, I want to make it an element. So for e in length, and len is going to, oh no, I'm using the built-in, of course. So this was the reason, so that I'll use len. By default it will return to me three, if here is three parameters or whatever. So and I'm going to make it into the range, so range by whatever is in the length. And yeah, here's going to be iterator, then our colon, and so basically what I'm going to do is just say summation is going to be 0 at first, but at last summation is going to plus equal I. So yeah, no, not actually I. It's going to, wait a minute, why do I use len here? Is I, if I can use just, yeah, element, and I can use self.x, which is basically goes through all arrays, so I don't need to explicitly put self.x and then iterator inside. So yeah, this will be the better one. So I'll just plus element. So basically what we do is, for example, we have 1, 2, 2 and 3, and then we take each of these like 1, and then we plus 1, and then we plus 2, which is going to be 3, and then 3 plus 3 is 6. So we're going to return to us 6, and I'm going to return this variable. So our summation method is going to work fine, and let's check this out actually. So what I'm going to do is probably the same things. So it's going to return us 6, m, and then sum, and that, okay, yeah, it's going to return 6. So now let's make something much more ambiguous, bigger. So what I'm about to do is I want to return I here, which is for I in range of let's 50. So we'll check this out, how much from the range of 0 to 49 in sense of summation. So and basically between 0 and 49, if we will sum everything inside them and them as well, we're going to get to get 1225. Okay, so it works fine. And so next what I'm going to do is, so to clear this console, I'm using command K. So command K is actually just clear. Okay, so okay, I like it. What else? Let's then now implement another one, which is going to be mean. So I'm going to calculate mean, and then of course self goes inside, and we return whatever will be the mean. Let's return m, which is going to be m just 0. So how mean works is we're going to take every parameter in our array and then divide it by the length. So this is basically where our length is needed. So okay, yeah, this is where our sum basically is needed as well. So we can actually erase this variable and just make something like that. We're going to use self.sum and then divide it by the length, which is self.len. So it's going to work fine. Let's check this out actually. So to make it a little bit easier, what I'm going to do is, yeah, I actually could not make like this. Just 1, 2, 3, 4. I'm typing it for the sake of simplicity. Of course, I can do here just 5, and then plus 1 is going to be the same thing. But for the sake of simplicity, I want to make it right now in such a way. So we're taking this array, and then we are using this, yeah, and then we're going to print our mean. So our mean, of course, here the object of the class m. So mean, and then parentheses. So it doesn't take anything inside. again, let's check this out for yeah, so we are taking sum, we're summing all the values in the array, and then we are dividing it by the length. So to calculate it manually, is it's going to be 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and 10 plus 5 is 15. So 15 divided by 5, divide by 5 because of the count of the elements. So we have 5 elements, and this is basically our mean. So our mean is going to be 3, and let's check this out. And we have 3. Yeah, we have the float one. Of course, we can put it into an integer type, but I don't want to do it right now. So, and by the way, here, of course, it's supposed to be int, because if it won't be an int, it will return to us very bad errors. So yeah, okay. I mean, just to be um, aware, I don't know. So okay, we implemented our means. So what I'm going to do now is to implement a standard deviation. Actually, for the standard deviation, we have everything what we need. So the formula of the standard deviation, basically for the first, at first I wanna just put standard deviation is and then return whatever, like 1. Okay, so now what is the standard deviation? So the formula of the standard deviation is that we're going to well, it's hard to say, but basically it's easier to show. So if I left here I left here the formula of the standard deviation. So this is our population standard deviation. Yeah, it's called population standard deviation, but you can call it even just standard deviation. It's just notation. So anyways, so we're taking the square root of something inside, something very not understandable for us, but I'm going to break this down. So basically this one is our basically our mean. Oh no, it's the sign of summation. I'm not sure how we call this because I'm not the sharpest stack in the box when it comes to the notation. So I'll just explain it in the simple language. So this is the sum of this, okay? So and basically this square is is belonging to this. So it's not belong to this. What basically means is that this takes all of this with the square root. Okay, well, I mean with the power of 2. So again, I think it will be much more easier if we will write it in the code, but basically what it says is that if you have an array such as this, 1 2 3 4 5, you are going to put the first value of an array, which is going to be 1, and then this is the mean, as you can see here. Oh yeah, okay, the population mean. So here's probably the link on the Wikipedia, is it? No, it's not. Yeah. Anyways, so we're taking 1, then minus mean. So mean of this, as we learned, it's 3. So 1 minus 3 is minus 2, and then minus 2 squared is basically 4, because minus goes away. So 4, and then what it makes is it keeps 4, and then it calculates 2. So 2 minus 3 is 1, and then 1 in the power of 2 is still 1. So then it takes the first 4, we got 4, and then it takes 1, so it takes 4 plus 1, and so on and so on and so on. Hope you got it. So and then what we do when we calculate the sum of this square difference, mean difference, I don't know how we call it, there is definitely notation for this. So we are dividing it by our length, so basically what we've made here, or in other words, the size of the population, which is length. So and then we take the square root. So okay, let's actually implement this, but as you can see, I forgot about the last one. So we have our mean, we have our length, we have the summation, but we don't have the square root. So how to make the square root? So this is quite tricky. So let me show you in the simple example what is the square root. What I'm going to do first is going to print to you 3 and the power of 2, and then it's going to be 9, obviously. So what I'm going to do now is make it in the power of 1. It's going to be 3. But what about if I'll make it in the power of 0.5? So it's kind of tricky, right? I know for that for most of you, um, you say, well, this is basically the square root. Yeah, and you're right. But for the other part of our theory, I will explain it explicitly. So yeah, first of all, let me explain it in such a way. So we have a free, as I've made it in the power of 2. Oh yeah, parentheses, I forgot about them. So yeah, so 3 in the power of 2 is going to result our 9, 9, and this is basically is this 2 um, divided by 1, which is 2. So it's going to result the same result, 9. So what I'm doing here is I'm converting our 0.5 into the into that 5 divided by 10, which is 0.5. So in other words, I can say 3 in the power of 5, which is, if I'm not mistaken, 283. Not sure about it. We can check this out. Yeah, 200. I said 83. Yeah, 243. Anyways. So and this is basically this 5 divided by 1. So here it's 5 divided by 10, which is 0.5. So what we first do is we calculating this power. So we're taking our um, mm, how we called it. We have discriminator and we have numerator. So we take our numerator and we convert it into 233. Okay, so I mean we power it in the power of 5, so we get 233. So we got 243. So and what we have basically right now is this. We have 3 in the power of this 1 divided by 10, which is basically zero point 0.1. So now this is going to result this value, which is if we will multiply it 10 times, we're going to get 243. And this is how it works. If you didn't understand it, watch it again. So if we will multiply it 10 times, we're going to get 242.99999, which is 243. So to check this out and confirm what I'm going to do, I'm not going to multiply 10 times manually like this. I'm going to just use our power. So as you can see, we've got 232.99999, which is 243 approximately. I mean, almost. So yeah, and if we will put here 4, somehow it will be 243. This is just what I've noticed before, but I mean, never mind. So okay, hope you got it correctly. So if you did not, watch this again. Okay, hope you will watch this again. But anyways, so okay, we spent already almost 18 minutes. So what I'm going to do now is I'm going to implement the square root. I believe this was needed, and ASQRT, which is square root, just in abbreviation. So I'm going to return whatever is self.x. And yeah, basically square root, we need to put an argument, so argument, and use this argument as our value actually. So and then multiply it into 0.05, or we can make it explicitly 1.2, which is the same as 5.10. But for the sake of less calculations, I'm going to use just 0.5. Okay, so we got our square root, so we're ready to get into the implementation of standard deviation. So let's get into the standard deviation. Again, you will get into it right now. For I in range of. So what is our range right now? So our range is no, I'm going to do the same things again, but I'm trying to go harder. So E in, yeah, it was just quotation. So E in what, self.x, of course. Self.x is, and then what we're going to do is we're going to calculate this square differentiation. No, difference, yeah. So diff, I'll just, yeah, make it a little bit shorter. So square diff is, no, yeah, which is in the power of square. I mean, in the power of 2. Anyways, so it's going to be is this. So we're taking x, which is our element inside our array. So we're taking element of our array, and then we are subtracting our mean, which is going to be just our method. Quite simple, so that's why we've implemented it, and then we just get it into the power of 2. So this is basically very easy. I mean, extremely easy. So we just yeah, raise it in the power of 2. So basically what we've got now is this. So we got our parentheses here, x, I is basically means the iterator, so basically means that our first iterator, then our second iterator, whatever. So element of an iterator. Okay, so we're taking our iterator and then minus mean, and then it's powered um, into the 2. So and then we're going to do the same things. We're not going to get into it now, but we are going to get it to it when we will end our array, which means that first of all I will go here, and then I'll go here. Oh, of course I need to first of all assign it. So again, um, I go here, and I take first element. So first element is 1. So I take 1 minus our minus 3. So 2 minus 2 minus 2 in the power of 2 is 4. And then I'm taking this 4 and keep it for a while. Then I do plus. So then I take the next element, which is 1. So I'm going to take 1 minus 3, which is going to be wait, is it? It's 2, of course. So yeah, we've passed 1, so we go into 2. So 2 minus 3 is going to be 1. 1 in the power of 2 is, I mean, 1 minus 1 in the power of 2 is just 1, so we plus 1. And then the same things we do now. So 3 minus 3 is going to be 0. 0 raised in the second power is 0. And then what we do next is we're taking, sorry for be so I don't know, nasty, or no, I think it's not correct word for this. Anyways, sorry for so long. I'm not the native speaker, so I don't know how to express this. Anyways, so we take 4, and then 4 minus 3 is 1, not minus. So 4 minus 3 is 1. So 1 raised in the power of 2 is 1, of course. And then the last thing, we were taking 5. 5 minus 3 is 2. 2 raised in the power of 2 is 4. So basically the same things. And then we're going to calculate our summation. Okay, so I'm here again. So what we're going to do is we're going to sum all of that. So 4 plus 1 plus 0 is going to result 5, and then 1 plus 4 is 5, so 5 plus 5 is 10. So we're going to get here 10. So what we're going to do next is, basically this is our sum sign. So we got here 10. Hope you understood it and got it. So now we're going to divide 10 by our length, or n, or size of the population. So basically after this we go here, and yeah, we can erase it. Hope it was helpful to understand a little bit clearly. So yeah, now what we're going to do is again, already we can return. So we use ourself that, no, first of all, for the sake of simplicity, I'll just take this and divide it by our length. So we take length and divide it. So actually we complete almost everything except the square root. So now I'm going to implement the square root. So the square root is going to be right now just self.sqrt and taking this parameter as input. So it's going to result as something pretty much good. I don't have a Wi-Fi right now, so I can't check this out, but I believe you can check this out. You just type here standard deviation, and oh yeah, I did implementation of this already. So basically, yeah, I already I've made so I've made the array here, and then I check this out. So it's going to result this, and let's check this out if it's going to be correctly. This is our result, so which we are expecting to get. Let's actually yeah, let's erase this as well. So print, and then we're using m, and then dot, and then std, and then parentheses. So the moment of truth, 1, 2, 3. No, we didn't get the good result, and the reason is, let's check this out, what we've made incorrectly. So we've got here, then multiplied by 0.5. So to be, yeah, let's check this out. So we go e in our self.x, and we are, oh yeah, of course, plus equal. So this is the very rude mistake. So plus equal, of course, because we are calculating the summation as it says here. Where is it? So yeah, so we're calculating this summation. Yeah, I've made a mistake when I said we have already summation. We don't have summation actually, because we can't just. We need to implement this, but we've implemented in summation just this. So it's sum the element, but not this little bit equation. So we actually don't use our kind of built method. We're using the new one a little bit, so we're using loop. Now the moment of truth again, 1, 2, 3, go. All right, here we are. So we got our result, which is going to be equal absolutely the same number and even more. So our website actually rounded it by 1, which is absolutely correctly. So we actually got a little bit precise value, even more than in our website. Which is pretty much cool. So this is basically it, and I hope this video was helpful. If you are willing to see how from all of this implement standardized data for data science, I can show it actually you right now. So let's make it. Video is already a little bit long, but anyways, so standardized data. Yep, of course, underscore, and then we're taking self, and what we're going to return, the formula is very easy. So we're going to take no, I forgot. Actually, I forgot. So I don't have the formula. Oh no, I have. So this is z is equal to xi minus mean. So we are doing pretty much the same thing, but we're dividing actually for by our standard deviation. So we already have it. It's going to be pretty much easy for us. So yeah, basically we are going to make the same loop, I believe. Yeah, so we need to do the loop again. So for element in self.x, we're going to calculate difference. Just let's call it difference. So plus equal to which is going to be equal element what was that, minus self.mean, I believe, right? Yeah, so this is how it works, and assign of course our difference, which is going to be 0, and now we're ready to return our standardized data. But do not be very fast, because if I'll make right now, if I'll make diff divided by the standard deviation, which is self.std, shorter, we're going to get just one value, but this is not what we are wanna have. So let's check this out. So I want to get the standardized data, and actually I got 0.0, which is probably correct. I don't know. So this is not what I want to have. I want to have just our data but standardized, which means that here is going to be represented as range from 0 to 1. Hope you got it. This means that I need to do an array, which is going to be just a, and then here. So inside this array, sorry for that. Inside this array, what I'm going to do is well, let me think about it a little bit. So I have this array, and then I have these values, and then they are standardized. So yeah, basically our array is going to append this. So this is this will be correct. Okay, so yeah, just diff, let's make diff just temporal. Okay, variable, we don't need it actually here. It will be just every time it will be equal to 1, then 2, then 3, and then minus mean. Basically the same things. So now when I'll return an array, we will get the standardized data from the range of 0 to 1. Let's check this out, and moment of truth. 1, 2, 3, go. Alright, we got it, but yeah, of course, it's not gonna be from range to 1 to, I mean, from 0 to 1. It's going to be standard, kind of differentiated. I don't know. Anyway, so this data is standardized, and I'm glad for this. So as you can see, our mean is going to be 3 because this is the center, and from this center we go like this and like this. As you can see, the difference is always 0.7, 0.7 between them, and between this and this is also approximately 0.7, which can be seen here. As you can see, we have this kind of graph. So we go from 0 to apart. So if you are familiar with this. So actually what we've made today is we've created a math class which is going to implement sqrt. Okay, I'm going to be implement squared root. Then what we've implemented is length. Did I? Is it correct? Spelling? I'm not sure. So again, I'm not native speaker. So and here summation, and we've implemented mean. So and standard deviation. Standard deviation. I guess I spelled it absolutely incorrectly. How is it? Devia, and then oh yeah, T. Just use T here. So yeah, deviation, and then standardization. Okay, guys, again, we've implemented square roots, then length, then summation, then mean, then standard deviation and standardization. So I hope this video was helpful and I could explain everything. So if you have questions, feel free to ask me in the comments below. And of course, this video for data scientists who want to start or who started or just started. Thanks for viewing this. Hope this was helpful. Bye bye.